So the cotangent is the last of our trig functions that we need to graph. There's some facts about the cotangent that might be helpful as we go through this process. Remember that the cotangent is cosine over sine. So the sine cannot be zero. We're going to get asymptotes wherever the sine is equal to zero. And then it's also the reciprocal of the tangent. So every place that the tangent is zero, the cotangent is going to have an asymptote. And every place that the tangent has an asymptote, the cotangent is going to be a zero. Okay. So let's go ahead and fill out our chart. Now, if we did the unit circle and if we did cosine over sine, our first location would, on the unit circle, cosine over sine would give us 1 over 0, which is undefined. So there is a vertical asymptote at 0 for our cotangent function. Pi over 4 is 45 degrees. Cosine over sine is square root of 2 over 2, divided by square root of 2 over 2, or 1. Pi over 2 is 90 degrees. The cosine there is 0, but the sine is 1. So we get 0 over 1, which is just 0. 3 pi over 4 is in that second quadrant. The cosine is negative, but the sine is positive. So instead of 1, we get negative 1. And then at pi, we get that 1 over 0 thing happening again. So we get a vertical asymptote. Now you're going to find that these ones are easier to visualize once you put them on the graph paper. So let's go ahead and put them on the graph paper. So at 0, cosine over sine got us that 1 over 0 undefined. And so let's put all of our asymptotes on. What's great about a cotangent, we're going to get 2 asymptotes because remember, that cubic looking thing is smushed between 2 asymptotes. So we have an asymptote at 0 and an asymptote at pi. As soon as we get 2 of those asymptotes, whether it's a tangent or a cotangent graph, fill up your graph paper with those asymptotes. So there's another one equally spaced at 2 pi, at negative pi, and at negative 2 pi. So again, I like to always put on my asymptotes on there if I can. The sooner you get the asymptotes, the better. Now, the cotangent graph hits the midline, hits the center at 0, and that's this spot right here, pi over 2. So let's put that on there. The midpoints are always halfway between the asymptotes. So we know there's another one here, and there's another one here, and there's another one here. That happens for both the tangents and the cotangents. The middle of our graph is smack dab in the middle of the asymptotes, and it's always hitting that midline. If we haven't moved it, if we haven't transformed it, if it's our parent function, the middle is at 0. But this is what's kind of interesting about a cotangent. This is pi over 4. At pi over 4, we found we're at a height of 1. And at 3/4, or 3 pi over 4, we are at a height of negative 1. So what's interesting is we get a cubic-esque sort of thing smashed between those asymptotes, but it is naturally flipped upside down. That is the natural state. That is the positive way that a cotangent looks. So what's weird is the positive version looks like what we associate as the flip of a cubic. Now, the reason that happens is just because this is the first quadrant right here, and the first quadrant, the cotangent value is positive, but the second quadrant, the cotangent value is negative. So it ends up just smashing it between the asymptotes in such a way that it looks flipped, but it's not. That's exactly the way it should be every time. And then let's finish all of those. Remember, these are periodic functions. Please go ahead and stretch those graphs across your graph paper. But I like a cotangent a little nicer because we find the asymptotes. There's the center. This one goes up, this one goes down. So it's pretty straightforward. So I think you'll actually have an easier time graphing a cotangent than graphing a tangent, just because those vertical asymptotes are a little bit harder to find in a tangent. And let me kind of zoom in a little bit here so you can see that. And then we'll look at some of the characteristics of a cotangent function. Okay. Our cotangent function, now we're talking about the parent function, y equals the cotangent of x. Just like our tangent function has a period of pi, it starts to repeat again after pi. All of our functions except for the tangent and cotangent have a period of 2 pi. Tangent and cotangent are the only ones that have a period of pi. The reason that happens is the tangent in the first and second quadrant start repeating again down at the bottom. The third and the fourth do the same thing. And so that's why we just get a pi before it starts to repeat. The cotangent skips all of the full multiples of pi. So 1 pi, 2 pi, 3 pi, 4 pi, negative 1 pi, negative 2 pi, negative 3 pi, 0 pi. All of those things it's going to skip. Now we're talking about the parent function. Because those things stretch like a cubic, the range is all real numbers. The symmetry is odd. So the cotangent of negative x is the negative cotangent of x. So the negative would flip out on the outside. That is because it has origin symmetry. If you flip it over the x-axis, it's going to look the same as if we flip it over the y-axis. And that only happens with our odd functions. So far, our odd functions are sine, cosecant, and cotangent. Those are the odd ones. The even ones are cosine, secant, and tangent. So 3 of them get blocked together. And when we took the notes in for the tangent, when you saw the charts, I put the 3 together that actually are either even or odd. And we'll explore the even and odd properties a little more in the next chapter. So let's look at our graph here for y equals the 3 times the cotangent of 4x. So let's write down our chart for our parent function. Remember, you want to always know those parent functions, and it's very helpful to write it on the side of the paper. So it goes from 0 to pi, and then we're going to break it down in fourths. So it's going to be 1/4, 2/4 or 1/2, and 3/4. And remember, a cotangent goes vertical asymptote 1, 0, -1, vertical asymptote. So those are the order in which our parent function goes. Now remember, the parent function is always going to guide us as to what's happening to our new transform function. This function has a stretch of 3. There is no flip, so our cubics will go that weird cotangent sort of way. The period normally is a pi, but we're going to set this entire term equal to pi. So we can go ahead and solve that for x. So you'll notice we have to divide off the 4. And so our period is pi over 4. Now remember, our phase shift is our start. That's where the inside of the parentheses equals 0. So it starts at 0. Our phase shift. We don't have anything added or subtracted. This function hasn't moved left or right. That's what a phase shift is indicating. Our ending, remember, is where we set that equal to pi. And then if there's no phase shift, those things will both match. And so we get pi over 4 again. Now let's think about if we break fourths down into 4 pieces, we're going to get 16ths. So I believe it's going to work like this. We're going to go 1/16, 2/16, 3/16, 4/16, which is 1/4. So, because this is, break it in half, so that's pi over 8. Break it in half again, that's 16ths. So we're counting by 16ths. 1/16, 2/16, 3/16, 4/16. So this one, we really, really, really have to break that down quite a bit. That 4 has smashed our graph in 4 times. So we'll just have to watch the way we put our graph paper on. Let's talk about our y values for a cotangent. The vertical asymptotes are always in the first and last spots for a cotangent. This graph has no vertical shift. So the middle is at 0. So this spot is on the middle, so it is at 0. Now, to find the new y's, remember we're taking 3 times the old y's plus nothing. So it's just 3 times the original y's. It's the only thing that has is a stretch for the y's. So if we multiply this one by 3, 3 times 1 is 3. If we multiply this one by 3, 3 times -1 is -3. So now we have a x and y chart for our new function. So our x's we have to break down all the way to 16ths. Our y's we need +3 and -3. Okay, so let's do our y's first because that's an easy fix. 1, 2, 3. 1, 2. I'm going right in the middle. So there's 5 of these. I'm going right in the middle spot. So like 2.5. And then so this would be -3. So I'm going that halfway point from one of those 5 by 5 blocks. Okay. So let's make this pi over 4. And let's make that -pi over 4. So if we cut that in half, that's pi over 8. To cut a fraction in half, just double its denominator. So if we cut it in half again, that's pi over 16. So I just kind of made my graph paper fit. Now, if you decided to make that like pi over 4, and then, there's lots of ways that you can do this. I'm just kind of, hey, I only need from 0 to pi over 4. So there you go. Okay. Okay, now we've got our little chart here. Let's use our chart to do that. And let me pick up my chart and set it right here so I can really zoom in. Okay. So just like a tangent, just like a secant and cosecant, finding the location of the vertical asymptotes is very, very helpful. So let's put on our vertical asymptotes first. We have a middle line at 0. We have a vertical asymptote at 0 and at pi over 4. So now we know the spacing. So we also have a vertical asymptote at -pi over 4. We don't have enough room on our graph paper to show any more asymptotes. We hit the middle line, smack dab in the middle of the asymptotes. So at pi over 8, we hit the middle. At -pi over 8, we hit the middle. Here we hit the middle. Here we hit the middle. Let me make that a different color. So here we hit the middles. They are equally spaced. They're always smack dab in the middle of our vertical asymptotes. Now we know for sure it's going to look like this. Okay, just a flipped upside down cubic is the standard normal form of these cotangents. So if we count at pi over 16, we are up at 3. At 3 pi over 16, we are down at negative 3. So like I said, the left side goes up and the right side goes down. As long as a cotangent isn't flipped, the left side goes up and the right side goes down. That's just the way a cotangent works. So this one had to be at a height of 3 so that my left side can go up. This side had to be at a height of 3 so my left side could go up. This side had to be at negative 3 so my graph could go down. Here we had to be at negative 3 so my graph could go down. This would be going down. So a cotangent looks like a flipped cubic naturally. So the only time it should look like a tangent is if we put a negative in front. So that is our first cotangent graph. Do we have any questions about that one? Okay, I'm going to let everybody make sure their graph is correct, and then we'll move on to one more example.
If the table says pi over 16 has a y over the y of 3, wouldn't it be the same on the left side? Well, on the left side it's 3 pi over 16 with a y of 3 and then pi over 16.
So the way that a cotangent works, from the middle line, if we go to the left, we're going to go up. If we go to the right of that middle, we're going to go down. So left goes up, right goes down. Left goes up, right goes down. Left goes up, right goes down from center. I don't know if that answers your question. And we are always smack dab in the middle doing that between the vertical asymptotes. So the left side goes up and the right side goes down. The left side goes up, the right side goes down. Left goes up, right goes down. The cotangent always does that. The left should go up and the right should go down. Unless we put a negative out front, it'll flip it. The tangent does the opposite. The tangent goes up on the right and down on the left. And it's just because of the way our unit circle is built and the way the quadrants hit these vertical asymptotes and thing. It's just kind of strange, but especially that a positive cotangent looks like a negative thing. I don't know. It's just the way it ends up working. Hopefully that answered. Okay, so now let's do one more. And then you can hopefully do your homework. Okay, so let's write down the original chart for the parent cotangent. At 0, we have a vertical asymptote. At pi over 4, we are at 1. At pi over 2, we are at 0. At 3 pi over 4, we are at negative 1. And at pi, we have a vertical asymptote. Okay, so that's our parent cotangent function. Now we're going to have, this one has, it has a flip, it has a change in period, it has a phase shift, it has a vertical shift. This one has a lot. So I think this is a really good place for us to end our notes for graphing. Because if you can do this, then you're good to go. Okay, so what are we going to do first? Well, the stretch is always the absolute value of our front coefficient. So our stretch is -1's absolute value, which is 1. There is a flip, and I always like to kind of write that down on that stretch line or by that stretch line to remind me. So normally our cotangent goes up on the left and down on the right. We should expect right now without, we should always expect now that negative in front is going to make them look kind of the way you would think they should look. Okay. Okay. Now what's the period? The period we're going to take our x term only and set that equal to pi. Remember, for tangent and cotangent, you use pi. Everything else use 2 pi. We're going to solve that for x by dividing by 2. Our period is pi over 2. Our phase shift, we're going to do the starting place for our phase shift. So you're going to set your parentheses equal to 0. Now that's the starting place on our graph paper. So that's really going to help us. We're going to add a pi to both sides and divide by 2. So we know right now that our new x value is pi over 2. Now let's find our ending value for our chart. Remember, we set the parentheses equal to our period, in this case pi, the period of the original. We're going to add a pi to both sides. So 1 pi plus another 1 pi is 2 pi's. Divide off the 2. Our ending is pi. Now from pi over 2 to pi is 90 degrees. It's pi over 2. So to cut that in half, we still have to count by fourths. And then cut that again, we're going to count by eighths. So let's think about that for a minute. How many eighths would that be? You guys are good with halves and fourths usually. You go past that, you start to overthink it. So this is 3/4, right? Okay. This is 2/4, 3/4, 4/4. Now let's go eighths. This is 4/8. So this is 5/8, 6/8, 7/8, 8/8. They should be equally spaced. That's a way to check your work. Let me show you again. This is 4/8, 5/8, 6/8, 7/8, 8/8. It's just things that are divisible by 2. If you cut them in half, they're going to reduce down, and that's what happened. So we need to count by eighths. So let's make, I think it'll work if we make that pi over 2 and that pi. They'll be smushed together a little bit, but I think we'll be okay. So that is the halfway mark. That's pi over 4. That's going to be pretty little. No, it'll be okay. So let's keep cutting those down like that. Okay, so we got our graph papers. X is pretty good. So let me just leave it there for a minute so you can see how I counted. You can, yeah, that's fine.
So that is where each full line is like a fourth.
Yeah, you can do that. Okay, so we found our phase shift was pi over 2. Let's put that on the line. Our vertical shift is this line right here, y equals -1. So let's make this -1. And let's put our midline on. Okay, so we've got our graph paper kind of going. Okay, now let's look at our y's. Our y's are going to be the opposite of the old y's minus 1. So this is where our old y's are going to sit. So the only thing on the outside is a negative and a minus 1. So that's going to be our, so if we look at our old y's, first, I love these because we don't have to do any math really. First and last spot are vertical asymptotes. So if we start here, the opposite of negative 1 is 1, is negative 1. Minus 1 is negative 2. The opposite of 0 is 0 minus 1 is negative 1. That 0 in the original should always be on the new midline, so it is. And then the opposite of negative 1 is 1, minus 1 is 0. Now we should expect that this one has flipped, so instead of going up on the left and down on the right, it should go up on the right and down on the left. Okay, so now I think we are ready to put our asymptotes on. Okay, we have an asymptote at pi over 2. We have an asymptote at pi. So put those on equally spaced for the rest of your graph paper. Smack dab in the middle should always be a point on the midline. 3 pi over 4, 3/4 is indeed, if I would have written it, this is 3/4, this is 1/4. Anyway, 3/4 smack dab in the middle should be on the midline. It says we were at negative 1. Oh my gosh, we are. So put all the middles on. That's what I like to do. All the middles always are on the midline for these. Now, 5/8. 1, 2, 3, 4, 5/8 is right here. We are down at negative 2. Put that on. So all the points to the left of middle are at negative 2. So put them all on. Remember, the patterns repeat. So those ones go down. And then at 7/8, 1, 2, 3, 4, 5, 6, 7/8 right here, we should be at a height of 0. Makes sense, right? So put all those on, because now on the right side we are going up to 0. So everything we thought has come to pass. They're squished together pretty good. The middles are down at 0. The stretch is still 1, but it's been flipped over. This time the left goes down and the right goes up, opposite of what we should think. So that is your cotangent graphs. If you look at the homework assignment, there's only 2 of them, problem number 2 and problem number 3. That's what should be turned in for the 8-2B homework. So for the rest of class, if you could please work on your homework. Remember, all late work is due by Friday. Please make sure that you get those things turned in.